Okay, how's everybody? All good? Good, good. It's okay, looking forward to the weekends. Who has class on the weekends? Class on the weekends? Class on the weekends? A lot of people. Well, I don't have any classes this semester over the weekend. Okay, good. So, who had a chance to have a look at bonus 2? Anyone? Bonus 2? Bonus 2? Okay, good. So, today, in our second half, we're going to be talking about UML. We're going to be using what you have hopefully been able to review during bonus 2, which is some information about UML. We're going to be doing this later today. Later in our 4 hours marathon. Okay? Okay. So today we're going to go hands-on. Today we're going to start with exercises. Okay? Now, I'll be covering those 3 topics: properties, the desk keywords, constructors. I'll be covering them via exercises. So as we go through exercises, as we need them, we will see how we will work with them, okay? So, yeah, second half, we're going to have some slides, but for this part here, with those exercises, we're going to be hands-on for the first half of today. It will be very lab-oriented for the first half, okay? So, let me see here a few things. Yeah. So here's what we're going to start from. If you can go to Centennial under Contents on week 2. So under week 2, I have 4 exercises here. Who has done those exercises by any chance? You have done? Okay. Anybody else? Okay, those exercises, as anything in this course, for some people may be basic, for some people this might be a bit advanced. If you have done and you want to move forward with exercises for week 3, you can do it. You can keep moving forward. Or you can help your friends as well. Lots of options for you. Okay, so with the exercises, let's have a look there. Programming exercise 01, version 2. By the way, by tomorrow, I'll be providing the solutions for all those 4 exercises, okay? So at the end of every week, I provide the solutions for the exercise of that week. And the way we're going to start doing this is I will do exercise 1, I'll demonstrate. You're going to have a look. You're going to ask me questions. Now you're going to see how it gets done. And then you will be doing exercise 2, 3, and 4. Okay? Okay. So let's get this done. Okay, so let's start by reading this. So, by the way, I made some changes with this exercise. If by any chance, if you have downloaded this earlier, I changed a little bit just so it becomes a little bit more, not simpler, but better structured. So I restructured it a little bit. That's the reason why you see the words V2 from version 2. Okay? So, create a project called Test Pizza. Okay, so let's do that. I'm going to open Visual Studio. I'll always be demonstrating via Visual Studio 2019. I'm going to click on Create a New Project. And I'm going to select Console App.NET Framework. Again, if you don't see this on yours, you can just type in Console App. make sure you select C#1 and the one that has .NET Framework, okay? If you want to follow through, as I will be doing, you can follow as well, okay? Feel free. Okay, and then the name is Test Pizza, okay? So let's call it Test Pizza. Look at this. When you create a project, it also creates a solution for you with the same name. So one solution, you can have multiple projects within a solution, okay? Like assignment 1. Assignment 1 is asking for one solution, 3 projects there, okay? So I'm going to keep the same name, Test Pizza for the project name, solution name, I'll keep Test Pizza as well. Let's click on Create. And then we have our class program, okay? Okay, so now, create a class named Pizza. So, what should I do next to create this class called Pizza? What should I do next? Where should I create this class? Where exactly?
Above the program class outside the class.
Above here, could be here, like class Pizza. And then we have this. Yep. Can it be there? Yeah, it could be. It can be above here, it could be below. But I'm going to choose another place that is not above nor below. Where else could I put that, this class?
Another class, creating another class.
Creating another class? What do you mean by another class?
Like click on the project and adding new class in the same project.
Adding a new, which will become a new?
Yeah.
A new what? A new?
New class.
A new?
So class.
A new class, yeah, this is a new class, but if I can also create a new file here, okay? So that's the option that I'm going to go for. So I'd recommend that keep each class in a separate file. It's a better structure, okay? It will be clear, your code will be cleaner, clear. It doesn't matter how small the class is, keep each class on its own file, okay? Is there anything wrong if we put it here, if we keep it here? Technically speaking, no. But from an organization point of view, let's keep them separate, okay? Let's keep a file for each class. So here's what I'm going to do. I'm going to right-click in the project name. I'm going to go to Add, and then New Item. I can go straight to class. I'm going to go New Item here. There is not much difference. I don't think there is any additional question, but I'm going to create it from here, Pizza. So this will become the name of the file and the name of the class. Okay? Great, so here we have. Now, it is complaining here because I'm not going to move the mouse over. I'll just let you think through it. Why it's complaining here? Where? In the program, yep. So I'm going to get rid of the other one. I'm just going to keep that one, okay? So now we are fine. Okay. Now what? Let's go back to the exercise. So we're going to create fields that will include a string for toppings, integer for diameter, and double for price. So we're going to create 3 fields, okay? So let's go back there. By the way, Padlet is open, so if you have any questions, you can post there. You can ask me here. Okay, so I'm going to go there, and I'm going to declare my data fields. What's next? What is the exact key that I have to press next here? Let's not talk yet about the access modifier. Let's just declare a string, toppings, okay? Just do that for now. So I'm going to say, like a variable, but we call this type of variable inside a class, we call them fields, data fields, okay? So I'm going to say string toppings. Okay, so you have briefly mentioned there, someone mentioned about private. The way it is right now, what is the accessibility, the default access of this field right now, of this data field?
Internal.
Okay, is internal applicable to members? Internal is only applicable to classes, okay? Good one, because again, internal is the most restricted one from a class standpoint, but it's just for classes, okay? Now, again, if not internal, what else this could be? Private. So the default access modifier that gets assigned is the most restricted one that is available for members. For members, we have private, protected, and public. So we have private, the most restricted one, protected in the middle, and public, the most available one, the one that is less restricted, okay? It's available to whoever, inside, outside. Okay, so now we know that this is by default private. But I'm going to ask you to put the keyword private there. And I'll tell you why. Because when we see the keyword private, we have no question that this is a private field. If we don't see anything there, we have to think and remember, and we have to have the knowledge that, oh, if there is nothing there, it means that it is private. Let's make it explicit. Make sure that you just state that it is private, okay? So, object-oriented programming, we make private data fields and public methods. Private fields, public methods. The data is always private. Let's make that as a rule. Technically speaking, we could make this public. But from an object-oriented programming, they should be private. Data, we hide data, okay? So let's take to that. Okay. Let's have a look at the other one. So we have toppings, we have diameter, and we have price. So diameter is integer. So int. And then we have another private, which is double, and that is price. Okay. Great. Let's see what else it says here. Okay, so now we're going to talk a little bit about properties. We have not spoken about properties yet, okay? So, as I said before, we usually, as a general rule, we keep data private and methods public. Not only methods, but methods and properties too. Properties is the way that the outsides can look and access data in the inside of a class. Let's try something here. If I declare a pizza object, if I say my pizza in the main, I'm declaring, now I need to instantiate. What should I do now? I need to use the word new, and then pizza. Okay? So now I can say my pizza, And if I put a dot, it will show me the properties, methods, fields that are public. So, of course, I don't see here toppings, but I want to have access to toppings. So, we could have a method, as in the last video from Joyce, she builds a method to get and a method to set. However, we're going to be using something a little bit more straightforward that will give us a get and a set right from within. And I'm talking about properties. Properties are the special data members of a class that will have a get and a set accessor, a getter and a setter, okay? So we're going to create them. We're going to create the first one for toppings, okay? Look at the casing as well. Check that we are using here camel casing. So camel casing for private data fields, Pascal casing for the property names, method names. I'm going to start to create our toppings here that will become our property. So I'm just going to say this, string toppings. And the way the syntax works is like this. We have a get, and we have a set. If I can type. Okay, so we have a get and a set, and we need to implement them. So you can think about this get and this set as kind of a method. They are both short versions of methods. The get will return a value. So you're going to say return, and we're going to connect this property to this data field by returning this value. So whenever the application needs to read the value of toppings, it will run this. Whenever the application needs to store, to write to this property, we're going to do that by using sets. And in the sets, we're going to do this. We're going to say toppings, which is where we are actually storing the data, is equals to what? Anyone? To value. Okay? So there is a keyword called value, which you can use inside sets. Imagine that value is a parameter coming through when we call the set accessor. Imagine that there is a parameter here called value. And value is the value that is coming in to the property. So we are storing and retrieving the value from our private toppings. This toppings here, this is just a middleman. It doesn't store, it does not store at all. It asks for the private property for the value, and it stores the value there as well. It's just, again, something controlling, being in the middle between the outside world and the insides of the class, in the data fields. It's there as a filter. That's where we can apply rules. We can say, you know what? If you try to set the toppings, I'm only going to accept if it's cheese, pepperoni, and olives. I could check that here. And I can say, if you try to send me any other topping, I'm going to break in your face. I'm going to throw an exception. And you handle that. So again, we could apply here. We're not going to be doing that right now because we're just getting started with this. So right now, we are doing something very simple. Reading from the private string and writing to the private string here, to the toppings, okay? Now, by default or by convention, we use the same naming for both property and data fields. Of course, one is lowercase, the other one is uppercase, the first letter. So keep them consistent, okay? Uppercase for the property, lowercase for the private field, camel casing, pastel casing, okay? Okay, let's try this. If I go here to our program, if I put the dots, will I be able to see toppings, capital or not? Okay, it's not there. What did we miss? Yes, yes. I'm just trying to see if I can catch you. Yes, it's a data member. If we don't set the access modifier, it becomes what? What is the default? Private. So we have to say public here. And let's go there, and now we should see toppings. And we can say toppings equals to, let's say, cheese. Well, pizza cheese should be by default, but anyway. Let's try something here. Let's see what is happening behind the scenes when we set this. Let's put a breakpoint, and now everybody should know what a breakpoint is and how to put a breakpoint and how to take a breakpoint out and how to debug and how to F10 and how to F11 and how to all those things. So when we do this, which one of these two will be running? Is that the get or the set?
Set.
Set is the one that is storing. So let's put a breakpoint here. Let's see what's going on when we try to do that. Let me start. Okay, so it stopped there. Look at here the call stack. Call stack just tells me who is calling what here. Where are we in the application? Oh, it's telling me that we are stopped in the main on line 15. So we are stopped right here. And then because it went through here, we are actually in this spot. So it shows me what is calling what, and this is called stack. Who's calling what in the stack? You know? So let's move the mouse over. So toppings, null. We declared here. We didn't initialize it. That's fine. It's expected to be a null string. But then look at the value. We have cheese. Now, if I just press F10, Control F10. Okay, give me a second because I just stopped the recording here. I went with the shortcut that stops the recording. Now I'm going to mess up the recording, but that's fine. I'll fix that. Okay, so as I was saying, if I press, I'm not going to press. I'm going to click the button here. So if I go a step over, and now toppings is cheese. Okay, so toppings became cheese. So when we do this, we use the setter. When we do this, console.writeLine, and I can say pizza topping, and I'm going to use string interpolation here, and I'm going to say my pizza dot toppings. Now, when I do this is not an assignment. I'm reading from it. So if I put now a breakpoint in the get will run when we need to get the value from the property. So if I run this again, now we are about to use get here. If you go back to main, we are on line 17. So it's right here, and we are reading the value. Right now, you see toppings must have cheese here. Why it's not showing? Okay. I don't know why, but it's not showing for some reason. Let me put here in the watch. Watch is just another. Oh, does not what? Let's see here. Let me just, so control F5, okay. Okay, I don't know what's going on there, but I should have been able to see here the value. I don't know why. It's not, oh yeah, so it might have been something temporary. Sometimes Visual Studio has some glitches, but yeah, toppings is now cheese. So now when I need to get the value, well, the get will run, and it will give me the value. So you see that toppings is, in a way, quite, I wouldn't say it's useless, it's very useful, but it's not capital T toppings that is storing the value. Toppings, capital T, is just a barrier between outside and the data field called toppings, okay? Questions? Anything comes to mind? We're going to repeat this, yes?
Yeah. So same thing we do with the constructor, parameterized constructor, and we initialize the value and we can retrieve. Then what is the difference between getter and a constructor, parameterized constructor? We can call the same way, create the object of the constructor class, and then initialize through parameterized constructor. Then we can also retrieve the values.
Yeah, so I'm going to assume that, are you talking about constructors? Yeah, we're going to be talking about constructors in a little bit down the road. But constructor is just, yes, you can initialize them, but that's done once. If afterwards you want to change that value, you're not going to call constructor again. You're going to call the properties.
Okay, I'm assuming here if we know something already, like employee name, then we can initially declare with the constructor, parameterized constructor.
Yes.
In case we want to increase, update their name or something like later on, or
Yep.
last name, then we call the getter
The
setup.
properties, yes, we call the properties, yes. So you can initialize in the constructor, but again, we're going to talk about constructors a little bit later. You can initialize there, and you can modify, change afterwards via properties, okay? So you're going to do this 3 times, 2 more times, okay? We're going to do this for diameter, and we're going to do this for price. I'm going to use a copy and paste here. Very careful when you're copying and pasting, because very easy to forget to replace things there. I forgot when I was demonstrating this to another class. So I'm just going to do this and copy and paste it twice. And I'm just going to use diameter. So I'm going to do the same for diameter here, but I have to do a capital D. Remember the type. Diameter is an integer. And then I have to read from diameter lowercase and write to diameter lowercase. The same thing with price. I'm going to use here price as a double. I'm going to create a property called price. And I'm going to return from price and set price. And we are done with our 3 data fields and 3 properties. Okay? Okay. Now let's put this in action. So I'm just going to do, actually, let's go back to the exercise and see here. So data field includes, so we did that, include properties to get and set for each one of the fields. We did that. in the main method of the program class, instantiate one pizza object and demonstrate the use of the pizza set and get. So when you read the word demonstrate, what does that mean? It means that give some output, use them, give some output, set them, read from them. You are demonstrating the use of those properties. So we're just going to do that. I'm going to say my pizza dot diameter equals to, actually let's use here. Pepperoni. Let's do this here, 12. And let's go my pizza again. Price equals to $13.99. Okay, so now we have the first one here. Let's write the other ones as well. And let's say size, and this becomes diameter. And then we have price, and this is price. And this becomes, and then we're going to format price as currency, so let's do this to format it as currency. Okay, so let's run this. Control F5, and we should be done here. And here we have set the values, and we are getting the values to display them. And we have question number 1 done. Any questions? Let's go back there to the codes. Okay. Exercise 1 and 2, they are extremely similar. So we're going to now practice this with exercise 2. If by any chance, as I said, this is too basic for you, keep going with the other exercises. If you are done with the 4 exercises, keep moving to the second week. That's fine. I'll be here to support as you progress, even if you are, doing something a little bit more involved than the rest of the class, or keep the exercise of the same chapter at the end of the chapter if you want to. But now we're going to do exercise 2. I'm going to give you some time. I'll be walking around, helping if you need some help. But now let's go through exercise 2. Exercise 2 is a new solution, a new project, starting based on what we have seen here. You're going to do this one as well. To make things a little bit easier, if you need, I'm going to copy this code and paste on Padlet so you can refer back to it. So I'm going to call this program. Use that as a reference point. And I'm going to copy the pizza one as well. So you can use that as well as a reference point. So pizza class and the program class there. Okay, so again, let's do exercise 2, and I'll walk around to see if anyone needs help with, okay? Again, as you get done, exercise 2, post that you are done so I have an idea of if we are done with that or not. Be there in a second. What's up?
I'm new to this class, and this is my first class.
Okay, welcome.
So I know what to do.
You don't? You don't? Okay, so maybe you want to start by watching the videos from the last classes.
Okay.
I mean,
So
let me see if you are. Yeah. So
I just checked the course
so-
outline and the
okay.
society.
So look here under week 2. Scroll down. See, this is the exercise that we are doing.
Listen.
Yeah. I just went through the first exercise. Okay? So you can go through the second one. The classes are recorded, so you can see the recording of the class. Go back here. Go to videos. You can see our section is 004. So if you click here, yeah, those are the past classes. So you're more than welcome to watch them.
And what's the upcoming assignments that's due?
The upcoming assignments, well, it's due in, let's say, 5 hours.
5 hours.
Yes.
That's
Well-
so much time given.
Yeah, but again, it was given 2 weeks ago.
But I just registered for this.
Okay, so get it done and show me the first thing next class. Assignments. You have assignments for. Again, talk to your new friends. You see, you have new friends here, so talk to them. Okay. Hello. Should I introduce formally or should I? You have a question?
Yeah.
No problem.
Basically, as given in here, we have to create a project with so-and-so name. But in the namespace, it takes the same name. right?
Leave the namespace. Don't mess around with namespace.
Yeah, because in the assignment you gave, it was written that namespace must only use slow.
Ignore that namespace part. I've copied that from another instructor, and there's a bunch of things that I don't. So the namespace part, you can ignore that, okay? Leave that. Don't worry about the namespace.
Assignment I actually put one small.
Yeah, don't worry about the namespace. Namespace, I don't look at that, nor the project name. I really pay attention to how did you call the class, how do you call the methods, the parameters. That's what I focus, okay? So again, I'd recommend to watch the videos of the previous class. You have, let's see, 8 hours of videos to watch. Maybe you can have fun this weekend. You can have, see, people binge watch. Is that binge watch Netflix? You can binge watch this class.
Sorry, I love YouTube, not Netflix.
Maybe you can bring, some friends to watch together. Can all have fun together. Are you saying that the videos of our class are not interesting enough for people to watch? Come on. They are. Okay. So properties, they use Pascal casing. Okay? Okay, I'm going to take a quick attendance here. So, Andrea, Anjali, new, Chloe, David, Dharmeek, Dinesh, Igor, Elgin, Eric, George. How. Hong Viet. Hong. Jayanth. Jayanth. Donekau. Jessica. Karanvir. 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 Kenneth. Kenneth. Krupan Bin. Ben. Krupan Ben. Krupan Ben. Michael. Nice Sarge. Nice Sarge. Osman. Philip. Philip. Rafsan. Rafsan. Raul. 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 Yep. Rafael. Robert. Siran. Siranjit. Two names. Siranjit. And then Siranjit. Sin. Sona. Thimin. Thimin Han Nguyen. Walid. Zian Pan. Zian. If I did not call your name, let me know.
It's done.
Yep, done. Okay, awesome. Okay, price value. Let me have a look at the class. Okay, so return value test. Okay, so you're using.
Because it's a similar name. It will
Got it. Got it. I see. I see. Okay. Okay. Good. Good. Okay, that's fine. Okay. Good. If you want to keep moving forward, exercise 3, you can keep going. So you have about 9 minutes to go. Yep. Okay. Be there in a second, okay? Last name again? Last name? Be there, 1 second. Just go here first. Oh, so you're going.
Just a bit, very silly question.
Yep, no problem.
I think the namespace name must always be lowercase.
That's okay. Namespace, yeah, don't worry too much about namespace. Okay?
They told me that you guys had a quiz.
Yes. Again, 3 weeks. This is the third one. So we're going to have another one next week already.
Can I do it right now?
Hold on, that thought.
Do you
What's
want
up?
to move on to the question 3 and 4 as well?
Yep, you can. Yep. Be back there in a second. Send me an email. My email is on Centennial. And then just mention that you need to do quiz 1, and we're going to do that next class. Okay? My email, if you go to the homepage of Centennial, it is there, but there's an easier way. There's an easier place. If you click the name of the program here on the side, if you scroll down, my email is there. So just remind me of quiz 1 and assignment 1. Again, get going with assignment 1 then. Okay? Deliver that by next class. Okay?
For assignment 1, I think I don't last part. You could help.
No, go ahead.
Which one are we going to?
Again, maybe I'll give you some time to look at those a little bit better, but I went through that again with the other. You have the binge watching that you have to do, so lots to catch up. Yeah. Okay.
Question 3 mentions constructors.
Yeah. No, keep going. I mean, again, if you know that already, by all means, be my guest.
Where I can find the call stack in the Visual Studio?
Okay, so you can go to View. Let's see here, other windows. One of those windows will show you that. Usually, by default, if you are running the application, and if you put a breakpoint, it will show. See, it shows automatically. Put a breakpoint and see if it shows for you already, because it may show. If not, again, let's see here. Look, see if you don't have a tab like this, tabs like this. You may have. If not, okay, so give me 1 second. It must be here, View. I'm curious now, you know, because it must be somewhere here. Now, I don't want to close it because I may not be able to find it again. But, exception setting, let me see something here. I have to figure out where is I. Just go drop, and I'll come back. Okay? Someone else calling already here.
I have the first example, but
Yep.
second in the error, it shows the
Remember to make method. You're creating methods there. Be careful. We are not talking about methods. We're talking about properties here, isn't it? So those are what you created there. It's not a property. This is a method.
so sector.
Yeah, you are not. Where is the set? Where is the get?
Yes, that's
No. You should look at the code that I provided there. This is not. You are creating methods there. We should be creating properties.
okay.
Look at Padlet. The code that I put there is very clear what is a set, how to do a set, and a get. Okay, go to the next one.
Yes. Okay.
See, get and set is like this.
Okay.
Quite different from methods, okay?
Okay.
Got it? Give it a try. I'll be there in a second. I'll be there. What's up?
I think I'm finished.
Awesome. Let me have a look at the house plans. Yep. That, okay, got it. That's about it. That's about it. Keep moving forward. You can go to exercise 3 and 4. Okay.
Saying error when it starts to run this, and I don't know how to fix this.
Okay, so let's give it a try here. So first thing that I see right away, name convention. So house, the name of the class should be H. It's not. This is not the problem.
Capital H.
Yeah, but it should be capital H. But that's okay. Can you show me your display house plans? So we have a main there.
Yeah, I was having some trouble with the Boolean, so I just commented that out, and then I was going to come back and fix
Got
it
it.
once I got the program
So
running. But
everything is saved there. Can you expand this dependencies here?
this one here.
Yeah, dependencies. Can you right-click the project? Right-click there. Not the solution. The project is the next one. Yep. Go to properties. See, you have created a class library.
Oh, damn it.
So I don't know if you can just change it. Try to change it here,
Yeah, concept. Okay.
and then hopefully it will work. But that's why it was not running.
Thank you.
Okay. Okay. Yep, you have a question? Yep.
In the last class, we saw a video about the author of the book, Joyce, about the Joyce that she's taught how can change the value of these variables using the methods.
Yeah, so we're not going to be using that approach. That approach was just an example of hiding the properties and displaying them potentially via methods, but instead of using methods, we're going to be using properties.
Okay, then always we need to use this.
Yes, we're going to be always using this. From now on, we have private fields, public properties. We're not going to be accessing the data fields from methods. We're going to be accessing the fields from properties like this. Okay?
And also, you also mentioned that for convention we need to use the same name, but with Pascal notation. That means that maybe I can use another name or something like that, or how can I always link the two things, the
By
properties
this,
with
by doing this here. See, here, this is the link. You are calling your name there.
But okay.
That's so the link is really that it's reading, it's getting from the name here, it's setting to the name.
Okay, if this is not the link, it's just a convention.
Just a convention. So again, it could be ABC. It would work the same way. Okay?
The link is the return and this.
Again, we are just naming them like this for convention. But technically speaking, they could have any name. Okay?
Okay, thank you.
Question?
And always this property, they have this return time, right?
Yes.
Always.
Well, yes, they always have. They are, because otherwise you cannot read from it. Okay? Actually, you know what? Let's have, if you need a break, take a break, take 5 minutes break, okay? I forgot to say that at 5:20. So again, take 5 minutes, we come back, we will carry on, okay? I got the call stack, Rafael. I got the call stack here. Debug, but only when you are running the application you have a breakpoint, okay? So you go debug, Windows, and then call stack. Okay? Got it?
question. Overloaded plus operator adds the same value. So I come here, I overload this operator, or it's giving an error.
It's giving an error there. I don't see it. Oh, move the mouse over there. Actually, let's try. Try this. Let's click here.
I think because there is already an operator defined for this double values, perhaps maybe that's why. No, but still we should be able to overload, yeah.
Whatever, promise. Let me check. There might be something minor there. Let me check. Then during the next exercise, we have a look at this again, because I'm going to start the next topic. But we're going to connect with that, okay?
It's not opening here.
It's not? What?
So,
Try again. It's stuck there? It keeps just there?
no, before it wasn't opening.
Oh.
It was giving a pop-up error.
It's scared.
Yeah.
It's scared. When I come looking, it's scared of me. Okay, so let's move forward here. So, exercise 2, very similar to 1. I'm not going to go line by line with that one, okay? What I'm going to do is, I'm going to check on exercise 3 and see which aspects of 3 you don't have yet, I have not covered yet, and then I'm going to demonstrate, okay? So let's have a look at 3. So 3, a project called test circles, create a project called test circles. Create a class named circle with fields named radius, area, and diameter. That's fine so far. Include a constructor that sets the radius to 1. Okay, so we have not seen a constructor yet. So let's cover that topic. I'm going to cover that topic, constructor topic, by going back to exercise 1, and I'm going to demonstrate on exercise 1 what is a constructor, how we can create constructors, okay? So I'm going to go back to our pizza application. And if you look at the main methods, which line are we calling the constructor of pizza? Line 13. So this is the constructor here. We call new, the keyword new, to allocate memory. And pizza, open parenthesis, close parenthesis, that's called the constructor. That's actually called the default constructor. Because if we look at our pizza class, we don't have a constructor defined here. We just have 3 properties with 3 fields. We don't have an explicit constructor here, okay? And the reason is because every single class that we create it comes already with a default constructor. We don't have to create our own constructor. It gives to us. The language, C# gives a constructor to us by default. And that's a constructor without any parameter like this one, like pizza there, okay? Okay, now, what if I want to create what if I want to define our own constructor? Well, we can. We can override the default constructor by creating our own. Let's do that. So I'm going to go back to our class, and by convention, we usually organize classes by having the private fields at the very top, then we define the properties, then we define methods and constructors, okay? So I'm going to go all the way down to the bottom of our class there, and I'm going to define, after the last field, I'm going to define our constructor. I'm going to say pizza And that's it. That's how I define my own constructor. Now, let's try to follow the example there. And here in the example, it says their constructor is supposed to set the radius to 1. Of course, we have a different class. So let's just set the toppings to a default value. Let's set to, I don't know, cheese. Because one of the main purpose of constructors is to initialize properties and fields, okay? So we are doing that here. I'm gonna say, anytime I create a new pizza, by default, toppings will be pizza. Oh, sorry, cheese, okay? Now, let's have a look at our program here. Well, I'm having a problem with pizza there. Why is that? It requires a parameter. Is that the problem? Because the constructor right now, there is no access modifier. It means that it is private. So it's not accessible from outside right now. So I need to make it public. So I'm going to say public pizza. And now it should be fine. So with that, every time I create a pizza, by default, toppings will become cheese. Now, it doesn't mean that I cannot overwrite that. I can change that. I'm changed right now. I'm set it to pepperoni. But let me put a breakpoint here. Let's see. Look, I'm going to move the mouse over my pizza. I'm going to expand the properties, and you see, toppings is set to cheese, okay? Because it's been set by default. We have set that in our constructor. So when we call our constructor, it calls this constructor here, which sets the toppings by default to cheese. Now, if I keep going here, of course, toppings will become be set to pepperoni. That's fine. It does mean that just because I've initialized that I cannot change its value. I can change the value. Okay? So if I go F10 here, and now it became pepperoni. Okay? Okay, so that's how you create a constructor. Let's see what else it's asked in the exercise here. It's not asking for that, but I'm gonna make one minor change. I'm gonna make another change here. I'm gonna create a second constructor. A second constructor that will allow me to create a pizza and to set each value for each property. I'm going to say this. I'm going to just reuse this. And I'm going to say, I'm going to set, because you can have a constructor with parameters as well. So I'm going to say string toppings. Those are parameters. String, I could call them anything I want, but I'm going to keep the naming convention by using the same names as the attributes, as the properties. So we have toppings, we have diameter, and we have, sorry, it's not string. This is an int. And then we have double price. Okay, so now capital toppings T, capital T toppings will be equals to receives toppings. So whatever is coming inside toppings becomes the new property value of toppings. I will do the same thing for the other properties as well. I'm going to say diameter equals to this diameter here. And I'm going to say price equals to this price here. So I'm going to say that again. One of the primary reasons behind creating your own constructors is usually to initialize the properties of that object, of that class, okay? That's what we're doing there. Now, I can just say, I'm going to create a second pizza here. I'm going to create pizza 2. And I'm going to say, it's pizza 2. And I'm just going to say that, you see, now, look at this. We have one of two. If I just use the arrows, I can see two constructors. I can see a constructor without parameter, and I can see a constructor with 3 parameters. So I'm going to say olives diameter, it's 20 inches. And this is a $39 pizza. And here, I'm going to print out the same attributes, the same properties, but now for my pizza 2. I'm just going to put a line break so everything does not come all together. Just going to say this. And let's try to run this. I'm going to Control F5. And here is what we have. We have 2 pizzas now. The first one set manually like this, property by property. The first one, yeah, the second one now set like this. With one single line, we are declaring, we are creating, and we are also initializing each and every single property. We are setting the properties already. Okay?
So the constructor, basically, it's like a method.
It is, and that's a good point. What is the difference between a method and a constructor? There are 2 nuances, two aspects that make them different. The first one that you can see there, what is it that one of those 2? Yes, so those are the 2. The name of the constructor is the same name as the class, that's one. And 2, it does not have a return type. You see here? No return type, not even void. Okay? If we had void there, this would become a method. Okay? Again, same name as the class, no return type. This is what makes them constructors. Now, when you see this, what does that remind you? See pizza twice, the same name being used there. Overloading. So what you see there is an example of constructor overloading. You have seen method overloading before. This is how you overload a constructor. Very similar. The same, we have the same name, of course, because constructor needs to be the same name as the class. But then we have different what? Parameters. First one doesn't have any parameters. The second one has 3. We could create another one that has 1 parameter, another one that has 2 parameters. We can create how many constructors we want. I mean,
It's the same thing that if you put in the parameter easy and the other one easy, is the same thing as the overloaded crash.
yeah, it will conflict. If you, the same rules apply. If you have the same number of parameters with the same types, it will not compile. It will say that, hey, there is already one defined like that. Okay? Does that make sense? I mean, is that, so that's our constructor, okay? That is constructors. Let's have a look. Any question about constructors? Again, mostly used to initialize properties it can be used for other things, like opening connections to the database, doing some initial configuration. But for the sake of our examples, we're going to be using that quite a lot. Maybe doing some calculation, okay? Okay. So we have constructors. Let's go back here to the exercise, the 3, and see if there is anything that we did not cover. Okay. So also include public properties, the radius. Oh, this is one. The radius property should have a get and set, but area and diameter should be read-only. So we have not talked about what read-only is. So a read-only property is a property that you can only, well, read. You cannot set. You can only get it. Because maybe for some reason, what you're doing, you don't want that value to be changed. Okay? So if I would ask you, how would you make diameter? Again, I'm just giving an example. There's no good reason to make it just read-only, but I'm just going to make an example of how could we make diameter read-only. What would we have to modify there to make it read-only? We just remove the sets. That's it. That's about it. We just remove that and it becomes read-only. Now, I'm going to get some errors here because I'm setting it here and also outside. So it gives me an error because now it's read-only. But that's how you can create a read-only property. Why would I create a read-only property? Maybe because that property is calculated. It's calculated based on other properties. Like the example here. The exercise. The exercise, we have so you see radial has a get and set, but area and diameter, they are read-only because with radius, I can calculate the area and I can calculate the diameter. Okay? So I don't need to allow the user to set the value. I can calculate myself. So you just need to read the value. That's the point of exercise 3 about this read-only. Okay? Again, exercise 3 will give you a chance to see that in action. But I'm going to revert back to a read and write diameter. Okay, one more thing here. Let's check what is this, what this is. Okay, lots of this and that, and again, it will become confusing, but we're going to get there. So, let me ask you this, and I'm talking about this code, okay? Not that, this, but this, okay? So we have those parameters called toppings, diameter, price. We set them up here. By the way, something very common, an error that happens quite a lot with students, and I'm saying a lot, is that those students, not you, but okay, those other students, they sometimes confuse this, and they flip them up. They put the lowercase, the uppercase gets a set to the lowercase. So again, very common to see that happening with the other students, not this class, okay?
We can change the name, right? Inside of the parameter.
I'm not talking about the names. I'm just talking about flipping them here. So use price lowercase here and price uppercase there. Okay? What we are doing here is whatever is coming via parameters, we are setting them to the properties, okay? So it does make sense to be the opposite, but I see that quite a little bit. Anyway, my point was a different one. We are setting the values to the properties directly, but can we change these directly? Instead of accessing the property toppings, can I, inside the class, can I access this one instead? Can I? I can, can't I? They are private, yes, but private just means that it cannot be accessed outside, but inside they can be accessed, okay? So, I should be able to say this, toppings, here. Now, I'm assigning directly to the private fields. No big deal about that. It's possible, okay? No big about that. And I could say the same thing here. Top, diameter, and price. But then, what is the question or the problem that this is not an error, it's just saying that, hey, something might be a bit off, you may want to have a look at this. What is the problem here? Huh? Same name. So the inside parameters, they have the same name as the outside fields. One way to fix that, very simple. What would be? Okay, so before we get to this, we could rename the fields, the parameters, isn't it? We could rename them. But let's not rename them. That's the easy out. Okay, that's the easy way. And it's not very beautiful. I want your code to be beautiful. And beautiful, it means that the names make sense. They don't have 1, 2, 3. They don't have those hacks. But then for this to happen, we have to use this. This. Okay? Because the keyword this, actually, to be honest, everything here, price here, they all have this implicitly there. It's just not showing, but it's there. This means that it is the current instance of that class. It's the object that is present at that moment in time inside that class. Now, don't get hooked up on that fancy definition. Just think that all of them, I could say this dot price and this dot price. I could say that. But look, Visual Studio itself is, see, it's light. It's a light color. It's the way that Visual Studio tells us that this is not, I mean, you don't need to do that. It's okay not to do that. It's okay not to use this. You can use it or not. Because here, whether you put it or not, there is no difference. It doesn't make a difference here. Because there is no conflict. However, here we have a conflict. Because we have toppings as parameter and toppings as the outside. So here, I could say this are toppings. And see, this no longer gets the dimmed color, the light color. It has a bright blue, which means that, okay, it makes sense to use this here because you need to differentiate toppings as a parameter and toppings as this private one here. So, I'm going to stop with this right here because, to be quite honest, very rarely you're going to really need to use the this keywords. There are a few situations, but we're not going to be talking about it. They will show up over time as we go through, but just keep in the back of your head that this is here, okay? This is in our code. This is in our code, okay? Referring to the current instance of that class. Okay, so I'm just going to revert this back here to what it was before. But that's it for the keyword this. Even toppings in capital T, I can use this here as well. Not required, but I could use every single reference there to non-static. And here is the key aspect. This is only supposed to be used for non-static members. Dynamic members that will change from objects to objects. Static members, you cannot use this, but that's okay. So this is the keyword this. Any questions about this? Just too many puns intended, or non-intended. Okay, so we have read-only. Yep. Properties this. Okay. Let's get going with the next exercise with 3. We may not get it fully done today, so you may take this home. Again, tomorrow I'll provide the solution for all 3 of them, but get going with exercise 3, and then in a bit, we're gonna jump to another segment here, but let's get started with exercise 3. Any questions so far? Anything? Again, with exercise 3, you're gonna be able to use constructors, you're gonna be able to use read-only properties. That's what you're gonna be practicing there. Don't get overwhelmed with how big is the exercise there. Break it down. One of our jobs as a coder is to get something this size and break it down into small chunks, into more. Okay, what are the different elements of this question here? Well, we have a class, we have fields, so start to break it down into smaller pieces, okay? Go for it. I'll give a few minutes and we will carry on. We'll keep going.
Getting the infamous Stack Overflow.
Infamous. I'm quite sure I know what it is. Usually that Stack Overflow is about you setting or getting not the property, but not the field, but the property. Let's have a look at your, you see, that's it. You see this capital A?
Oh.
That's about it. So it should return lowercase area, not uppercase area.
Okay. Yeah.
Going to send me that problem?
That just worked.
Oh, it worked?
I mean,
Maybe sometimes Visual Studio is a bit buggy and you close and you open again. So it worked. Okay, good. Yeah. Okay, so so the last one you did. Let me have a look at circle again, the class. Okay, perfect. So we have the structure here, and then okay, this will work. The only Can you show me the area? Scroll down. Yeah, okay, this will work. However, the exercise is asking actually to make this calculation right here when you set the radius. So this math that you are doing, they should be set inside of the set. This will work, it will give
Just
the right
return
answer.
the value here only.
Yes, and then return the value 1. Yeah. Yep, be there. Just squeezing. Thank you.
I don't know, my Visual Studio was working fine. It's just that it crashed on its own.
Yep.
And then when I open it and now I'm coding, it gives me an exception. There's no error in the code.
Yep.
But whenever I try to execute, it would just give me an exception. It goes
Application is in break mode. I'll try to reboot your system there. Okay, give it a try. Okay. No problem. Sorry about that. Yep.
So the number 3. So
To set radius there for 1, 2. In the third one, you don't set radius. Go back to the class there.
data is 2.
Okay, so
Yes.
recalculate. Okay.
Because they say
That's
the
good.
radius,
That's good.
right?
Yeah, that's good.
To set.
Scroll down.
And the area they say just
Yeah.
keep
Keep
read
going.
only.
Scroll down.
And
Yep.
they say one of the constructors radius 1.
Radius
right?
1. Yep. That's fine. That's good.
Question.
Yes.
Why this? Because I
Okay.
didn't use at all, right?
Okay. We're just giving an example of a class called circle and some properties. You can set what you did. You create a class called circle. It expects a radius. If you set the radius, you calculate the diameter and you calculate the area.
But I said that the radius over here, so they are going to the 2 is going to replace this number, or
Which 2?
you should put 2 here?
Yeah, so this will. But for the third one, you're not going to set the radius. For the third one, you're going to leave the radius as 1, and you're going to get the values.
So just say like
Create, declare,
sec003, but doesn't need to
set the radius, because it will be
doesn't
done,
need to give the value
because it's already given
because it doesn't give
as 1.
So it's like a method of the optional.
Kind of, yeah.
Yes. Try to. Okay.
Because again, if you want just to create, the default value of radius becomes 1.
But I need to say this because once I say everything here, I need to.
Yeah, because otherwise area and diameter will not be visible from outside. See, go back here.
Oh, yes.
If we have just the private ones, they won't be available here.
Because how they are going to calculate the area is because it's private.
Yes, and then we return the privates here. Private area, and then private diameter here.
Oh,
Okay?
okay. I guess when this become bigger, it's so complicated, but
For now, I mean, it's quite simple, isn't it?
no, yeah. Just I guess need to do like a flow chart.
Okay, okay. Do what you need to do to make your notes make sense to you.
Yeah,
So your notes-
to link all these parts that
Uh-huh.
usually is the best make notes or make connection, right?
Yep. Okay, so let's keep moving forward. I'm not gonna go through the exercise 3 right now. I'll be providing the solution tomorrow. Are there any questions that you would like to sort it out right away about that exercise? Any questions come to mind? By the way, someone asked to upload the code to Padlet, so I just posted the constructors here as well. Again, tomorrow we're gonna have all 4 exercises, the code for each one of them uploaded to Centennial. Again, any questions? Keep going again as you go through it. If you have, let me know. I'd like to wrap things up with this first half by going back to properties and talking about one more topic around properties. Let me see here. Okay, I'll keep checking Padlets. Okay, so in terms of properties, there is something. There's something called auto-implemented properties. What are auto-implemented properties? Well, it's a property that you don't need to write a getter and a setter. So get and set, they are called accessors, property accessors, okay? So there is a way that you don't need to write this down. Look, our properties right now, they are doing something very simple, extremely simple. They are just reading from a private and writing to a private, reading from it, writing from it. Very trivial, very simple. Because this is so trivial, there is an easier way that we could have written those. We could have used auto-implemented properties. Look at this. You see what Visual Studio is telling us? It has the private fields in this light color. Again, this is usually when Visual Studio is thinking, you know what? There is a simpler way. You don't need those. There's another way. There is a simpler way. The simpler way is this. I'm going to comment this out, these toppings here. And I'm going to rewrite our toppings property. I'm going to copy this and comment this out to eliminate, because I just want to do this temporarily. So I could do this, and I could simplify my get and my set. I could do something like this. Get and set. Quite simple, isn't it? But when we do this, we are getting rid of our private fields. We no longer need them. So we got rid of this, and we just wrote our property like this. Again, an auto-implemented property. Auto-implemented, why? Because we don't need a private field, a private variable, to read from and write to. We don't need that. But behind the scenes, here, there is a private property. There is a private field, but we just don't have access. So we don't need to have access. Now, we can interact directly with toppings. But here's the thing, here's the limitation. In your exercise 3, it asks you to calculate the area and the diameter, wasn't it? From the circle. You have the radius, you calculate the area and the diameter based on that radius. It asks specifically to do that in the set accessor of the radius, to calculate both of them. If you use this, you cannot do that. You cannot write any codes in the setter and in the getter. You cannot write, because those are auto-implemented properties. So that's the limitation. Yes, it makes things simple, but you are limited to what you can do inside the get, inside the set, because you don't have inside anymore. That's it, just that. There's no implementation of get, no implementation of set. You cannot write inside of them. But it is an option, it is an alternative to writing like this. Again, we no longer have a private field, but behind the scene it's still there. However, we just don't have access. Now, in the future, later, if you do web application development with me, if you take with me, you're going to be able to write this. That's fine. For now, for the sake of this course, we're going to be always writing like this. Why I say that is because maybe some of you have already experience with that other thing there. But at least now you know that, yes, they are auto-implemented. However, you should not use it through this course. The reason is simple. Because once you get used to this, you know what's really going on, what's really happening behind the scenes. Once you get to know how things really work, then you go the simpler route. But let's not start with the simplest route, because then you bypass the knowledge that you acquire when you practice using this, using the approach of fully implementing a get, fully implementing a set. Later on, you can reap the benefits of writing less code with an auto-generated one. But for the sake of this course, unless the exercise says explicitly use auto-implemented properties. If it doesn't say that, you don't use. You do this. For each property, you create private fields, public properties. Anyone?
Yeah,
yes.
But in this course, we're not going to use the auto.
Yes. But it exists. It's there. And if you get tempted to use that, unless, again, the exercise says to use them, because you may come across in the book exercise that will say, use the auto-implemented. that's okay. The exercise is asking for that. So you can show that you know how to do that. But for instance, in the tests, I'm not going to ask you to do that. Okay? So the default behavior of our properties will be like this one here. We have private fields, public methods. You're going to read from them. You're going to write to them, fully implemented, like that. Okay? Does it make sense? Why we make this harder, isn't it? Because there are things that, again, it's good to web application development. There we could use templates that would build the solution for us automatically and all beautiful for us. But again, those easier routes, they don't allow us to learn some of the basic things that we require to learn. Otherwise, again, what if you need to one day to write a full get or full sets because you need to apply rules to those, then you don't know how to do that. You have no clue on how to do that if you are just using the short version, okay? Awesome. I hope that I have convinced you to use the more complicated stuff. I hope the speech was good enough. Okay, let's see here if we have any questions there. Is C# purely OOP? So, you see, object-oriented programming is really an approach to programming. Yes, C# gives you the tools to use object-oriented programming. But could you write your applications as procedure-based? You could. But again, the simple answer to that is C# purely OOP. Again, I don't know really what purely means there in that context, but let me put it this way. It cannot be more OOP than C# is. C# implements all the basic aspects of object-oriented programming like inheritance, polymorphism. Those are the OOP basic aspects, you know. So I would say that the short answer is yes. If you want to unpack on that, I can have a look later. Multiple inheritance. Okay, good points. Again, we're going to talk about this when we get to inheritance. There is a strategy to quote-unquote simulate multiple inheritance, which is called interfaces. Again, we're going to talk about this a little bit later in the course, but we're going to cover this in the course, okay? So if you say that purely OOP needs to have multiple inheritance, yeah, there's a workaround. There's a bit of a hack that C# does. Again, whether this is okay or not for you, maybe you want to dequalify C# from purely OOP. I think it's too philosophical of a conversation, but that's okay. Okay, we're going to move on to UML, but before that, let's have our 15 minutes break, and once we come back, we're going to jump to diagrams UML. Okay?